Good evening, dear students. So last class we have completed the haloalkenes and haloarenes, right? So today we are going to start with a new topic, that is alcohol, phenols, and ethers. Okay. So what do you mean by alcohol, phenols, and ethers? Can anybody tell me what are alcohols, what are phenols, and what are ethers? Yes. So alcohols, phenols, and ethers, right? They are the organic compounds, right? And which are having the different functional group. So how do you represent this alcohol? Yes. How do you represent the alcohol, students? So it is represented by, so when you consider the word alcohol, okay, so what functional group it has? It has a hydroxyl group, okay, OH group, okay, OH group. So when the compounds which has OH group, okay, they are classified as the alcohol. The category they classify them as alcohols, right? Then so alcohol group. So the OH group, that is your hydroxy group, it is attached to a aliphatic carbon. Okay, so and when an alcohol group, when it is attached to a aliphatic carbon, then they give rise to the compounds called as what? They give rise to the compound called as the alcohol. So alcohols are represented as ROH. Okay, how are they represented? They are represented as ROH. Yes. Fine. Okay. Then, how are phenols represented, students? How are phenols represented? Yes. So, phenols, okay. So, the hydroxy group, the OH group is attached to a benzene ring. Okay. That is a aromatic ring. So, when the hydroxy group is attached to a benzene ring, which is connected next to an aromatic ring. Okay. Benzene ring is what? It is an aromatic ring. Then we give the class of compound, the name, we give them as phenols. Okay. So, alcohols, how they are represented? The hydroxy group, okay, the functional group, that is a hydroxy group, it is attached to the aliphatic carbon, okay, that is ROH. So they are represented as what? The phenols. And in sorry, they are represented as alcohols, and in phenols the hydroxy group is attached to a aromatic ring, okay, it is attached to a benzene ring. Then we give this class of compound as phenols. Okay, they are named as what? They are named as the phenols. Yes. Then the next class of compounds we are discussing is the ethers. Okay, ethers. So ethers, they are represented as ROR dash. Okay, ROR dash. So they have a this linkage. What linkage they have? ROR dash linkage. So R and R dash are your alkyl. Okay, it can be any alkyl or it can be a aryl group. Okay, it can be alkyl or aryl group. What do you mean by alkyl? Alkyl means what? Now suppose I have methane. So one of the hydrogen, okay, we are removing one of the hydrogen, and so instead of methane, okay, that is methane, okay, METHANE. So ANE is replaced by YL. So we call it as methyl. So we are removing one hydrogen, you get CH3. So alkyl, or you can take any aryl group. Okay, then they are called as, so this type of compounds they are called as ether. So the general formula is RO R dash. So R and R dash can be your alkyl or the aryl group. Understood? Okay, so this is the simplest definition. Okay, how you represent alcohol, phenols, and ether. So in alcohols, the hydroxy group is attached to aliphatic carbon. It is represented as ROH. Okay, here you can see. And in phenol, the OH group is attached to a next to a benzene ring, okay, or a aromatic ring. So this is a phenol. And ether, it has what functional group? RO R dash. So it has a O linkage, okay, ether linkage. So these are the compounds. So like this, we classify the compounds. Is it clear? Yes, right? So alcohols, they are the derivatives of what? So after seeing the functional group, so how do we explain them? So alcohols, they are the derivatives of aliphatic hydrocarbons. Okay, they are the derivatives of aliphatic hydrocarbons in which one or more hydrogen atoms, they are replaced by the hydroxyl group. Okay, so that is the definition of your alcohols and it is represented as ROH. Then when we are giving the definition for phenol, okay, phenol, these are what? They are the derivatives of what? Aromatic hydrocarbons, okay, in which the OH group, where it is attached, it is directly attached to the benzene ring or the carbon of the aromatic ring. Okay, so they are termed as phenols. Okay, yes. Then ethers, how do we represent ethers, students? Yes. So how do we represent ether? So ethers, they are what? They are also the organic compounds which is having this linkage, okay, O linkage, okay. And so this is the functional group which is present and how they are represented generally RO, R dash. Your R and R dash, as I have said, it can be a alkyl or a aryl group. Okay, is it clear? Yes. So moving forward, so let us see the classification. Okay, let us see the classification of alcohols. Okay, and yes, so let us see the classification of alcohols and phenols. Okay, so based on the number of OH group, so the alcohols are based on the number of OH group. How many OH groups are present? They are classified as mono, di, tri, poly. Okay, based on how many number of OH groups are present. Mono means the word mono is used when you have one OH group. Okay, di means when you have two OH groups. Tri means three OH group. More than three, any number, 4, 5, 6. Okay, they are called as a polyhydric compounds. Okay, so depending upon the number of OH group, the alcohols can be classified as mono, di, tri, or polyhydric compounds. Okay, so if I give you the example, so here, so CH3, CH2OH. Okay, so what? How many number of OH groups are there? Only one. So they are called as what? Monohydric. Okay, they are give the word as monohydric alcohols. Now, I'll give you another example, CH2OH and CH2OH. So here how many OH groups are there? Two OH groups are there. So it is called as, they are termed as dihydric alcohols. Okay, dihydric. So depending upon the number of OH group. Okay. Then one more example I'll give you. So CH2OH, CHOH and CH2OH. How many OH groups are there here, students? Yes, how many OH groups are there? Three OH groups are there. So they are termed as the trihydric. They are termed as what? Trihydric alcohols. Okay, trihydric alcohols. So first classification is based on the number of OH group. I hope this is clear. Yes? Okay, fine. Now, when you see with respect to your, this is for your alcohols. Now we'll see for phenols. Okay, now we will see for phenols. So phenol, so this is your what? Phenol. Okay, so here you have what? Okay, if I give you this compound, so this is orthocresol. Okay, orthocresol. So there is how much OH group? One OH group. So it is a monohydric. Okay, this is termed as monohydric. So because only one OH group is present. Now this one, another example. Yes, try to answer. So how many OH groups are there? Two OH groups are there. Okay, the name is catechol. Okay, and how many? So it is a dihydric. Okay, dihydric. Why dihydric? Because two OH groups are present. Then what is the compound name? Yes, anybody? So the hydroxyquinone. So the name of the compound is hydroxyquinone. Okay, so again, this is a dihydric. Okay, two OH groups are present. Then here you tell me. Yes. How much? 3 OH groups are present. So it is a trihydric. Okay. So trihydric alcohol. Okay. Trihydric phenol. So the name is hydroxyquinol. Okay. This is hydroxyquinol. Fine. Yes. So they based on the number of OH group, alcohols and phenols are classified as monohydric, dihydric, trihydric, and polyhydric. I hope the first classification is clear. Yes. Okay, fine. Let us go for the next one. So these monohydric alcohols, okay, they are further classified based on what? The hybridization, okay, where the OH group is attached. Okay, the first classification was based on the number of OH group. Now here the classification, so further we are classifying based on the type of hybridization. Okay, so when the OH group is attached to directly to a one carbon, okay, then they are termed as the primary carbon. Okay, and here the OH group is attached to the carbon which is attached to another two groups. Okay, then they are called as the secondary carbon. And the OH is attached to the carbon which is attached to three groups. Okay, then that is a tertiary carbon. So based upon the OH group where it is attached. So, okay, the OH group is attached to the carbon atom. Okay, so further to which carbon it is attached. So based on that, it is classified as primary, secondary, and tertiary. So here the OH group is attached to the carbon, which is attached to only one carbon atom here. Okay. Here the OH is attached to the carbon further, which is connected to other two alkyl groups. Here the carbon atoms has further three. It can be connected to three other groups. Okay. So it is tertiary carbon. So further, this is the classification. So your alcohol where the OH group is attached to an sp3 hybridized carbon. Okay, it is a sp3 hybridized carbon. This carbon is what? It is a sp3 hybridized. sp3 means what? The carbon is singly bond, right? Yes. So they are further based on that. They are further classified as primary, secondary, and tertiary. So let me give you example. So if I give you example here, so CH3, CH2OH. So what is the example? So this is a primary alcohol. Okay. Then CH3, CH, OH, and CH3. So this is a secondary alcohol. Then CH3, C, CH3, CH3, and OH. So this is a tertiary alcohol. Why? Why is the reason? What is the reason here? So here the OH is attached to the sp3 hybridized carbon. Okay, only one alkyl group. Here the OH is attached to the sp3 hybridized carbon of two aryl group for the alkyl group, and here the sp3 hybridized carbon attached to three alkyl groups. So it is a tertiary carbon. Okay, based on where the OH group is attached. I hope it is clear. Fine. Yes. For moving further, allylic alcohols. There is something called as allylic alcohols. We have seen in the this also where in haloalkanes and haloarenes also. What are the allylic, right? Allylic carbon there. So here allylic means what? In this alcohols, the OH group is attached where it is attached to the sp3 hybridized carbon, which is next to a carbon-carbon double bond. Okay, we have seen allylic halides. Same way, this is allylic alcohols. Okay, in allylic halide, the halide is attached to the sp3 hybridized carbon, which is next to a carbon-carbon double bond. Here in allylic alcohols, the OH group is attached to a sp3 hybridized carbon, which is next to a carbon-carbon double bond. Okay, so this is the allylic alcohol. So these are the three examples, okay, of primary allylic alcohol, secondary allylic alcohol, and tertiary allylic alcohol. Okay. Next is the benzylic alcohols. Next is what? Benzylic alcohols. So here the OH group is attached to the sp3 hybridized carbon atom, which is next to a aromatic ring. So here you can see the OH group is attached to a sp3 hybridized carbon atom, which is next to a aromatic ring. So again, sp3 hybridized carbon atom which is next to a aromatic ring. So sp3, so this is the sp3 hybridized carbon which is next to a aromatic ring. So please remember the definitions of allylic alcohols and benzylic alcohols. Yes. Examples are also important. Next is the compounds containing the OH group. Okay. So here what you can see, the OH group. Okay. The OH group is directly attached to the carbon which is next to a carbon-carbon double bond, and they are called as the vinylic alcohols. What they are called as vinylic alcohols. Okay. So OH group is attached to the carbon. Okay. sp2 hybridized carbon which is okay, which is bonded to a carbon-carbon double bond. Okay, so they are the vinylic alcohols. Okay, I hope the benzylic alcohols, vinylic and allylic alcohols are clear. Yes. Next, we will see the nomenclature. Next, we will see the nomenclature. So when we are naming the alcohols, okay, the common names of the alcohols, how they are derived, when we are giving the common name, we have to give first the alkyl group and then we have to give the word alcohol. Okay. Now suppose you have this CH3OH. Okay. So what is this group? It is a methyl. So first I will name the alkyl, that is a methyl, and then I'll write the word alcohol, methyl alcohol. Similarly, CH3CH2OH. Okay. When you have two carbon, it is the ethyl. So OH is there, so it is ethyl alcohol. So common name, we are giving it like this. Okay, first we have to give the alkyl group and then we have to add the word alcohol. Okay, then when we are naming according to IUPAC system, okay, when we are naming it according to the IUPAC system, how we are going to name it, students? IUPAC system. First, you have to, they are named as what? Alkanols. Okay, they are named as what? Alkalol. Okay, the in IUPAC system, we are naming it as alkanol. Okay, alkanol. So how? How? So by, so whatever the name of the alkane is there, okay, alkane, we are replacing this E. Okay, we are replacing the E, okay, of this primary, we are replacing the E by all. Okay, by all, OL. So it becomes alkalol. Okay, so suppose I have this compound. Okay, suppose I have this compound CH3, CH2, CH2OH. Okay, what is the common name? 1, 2, 3 carbon. 3 carbon means propane. Okay, so now, but this is a alkyl, so it is a propyl, and then you have a OH group and it is alcohol. Okay, now when I want to give the name, okay, so please name 1, 2, 3. So how you are going to name? Yes. So IUPAC name. So it will be alkanol. Okay, alkanol. So what is the name? Propane. So propane. Okay, and propanol. So at one position you have that OH. So propane, one on. Okay, like that. Understood? Yes. So again, one example I'll give you. So in IUPAC system, we are naming it as what? Alkanol. Okay, so these are the names. So you can see methanol, methanol. Then here 1, 2, 3. So N-propyl alcohol, propane vanol. Then CH3CH. Okay, CH3CH, OH and CH3. So 1, 2, 3. So it is again propane 2-all because the OH group is present at the second carbon. Okay, so it is propane 2-all. Again here 1, 2, 3, 4. So it is butane 1-all. Then here CH3, CH2, CH, CH3 and OH. So 1, 2, 3 and 4. So again what? Butane 2-all. So you have to see that the OH group should get the least number. So I'm naming it from this side. If I name it from this side, this carbon will get 3 number, right? So OH will get 3. But whenever you are naming the substituent, the substituent should get the least number. Okay? Yes. Understood, right? Yes. Okay. And whenever you have a secondary carbon atom, now here you see This, okay, so we have seen 1, 2, 3, 4, 5. Okay, now what is the common name here? So CH3, CH2, CH3 and OH. So here the OH is attached to the carbon. Okay, sp3 hybridized carbon, which is next to two alkyl groups. So this is a secondary butyl alcohol, right? Yes, secondary butyl alcohol. Then here you see the next one. So CH3, CH3, CH2 and OH. How you are going to name this? How you are going to name this? CH3, CH3, CH2, OH. So 1, 2, 3. No, 1, 2 and 3. So what I'm going to get? So this is a substituent. So I'm going to name it as 2-methyl propane 1-ol. Okay, 2-methyl propane 1-ol. Similarly, CCH3, CH3, CH3, OH. Okay, how you're going to name this? How you're going to name this? So 1, 2, 3. So at second position you have methyl group. So 2-methyl propane, and at second position you have OH group. So 2-methyl propane 2-ol. Okay. Yes. So these are the naming nomenclature. Similarly here, last one, CH2, CHOH, CH2OH. So here what I am going to get? 1, 2, 3. Okay, so 1 at 1 position, at 2 position, at 3 position, you have alcohol. So it is propane 1, 2, 3. How many alcohols are there? 3. So it is propane 1, 2, 3 triol. Okay, yes. So this is the IUPAC nomenclature. Yes. Moving further, when we have cyclic compounds, okay, we have to use the prefix cyclo. We have to use the prefix cyclo. Okay, and you have to consider the OH group which is attached to the carbon 1. Now here also, so this is what cyclohexanol. Why hexanol? Because 1, 2, 3, 4, 5 and 6. So cyclo, so it is a hexane. Okay, E will be replaced by all, and there is a cyclic ring, so we named it as cyclohexanol. Okay, then again 1, 2, 3, 4 and 5. So the substituent is methyl, so 2-methyl, okay, cyclo, what is that? Pentanol. Okay, pentanol. So this is the nomenclature. I hope this is clear. Yes? Okay. Moving further. Yes. So let us see the. So we will see the nomenclature for the phenols also. Okay. Here we will see the nomenclature for phenols. So when you are naming the, when you are giving the name for the phenols, okay. So the parent member, okay, the parent member of the family will be your phenol, okay, and the other members, okay, of the phenol, they are called as the derivatives of phenols. Okay, they are named as derivatives of phenol. Okay, then according to IUPAC nomenclature, based on the position, it is also indicated as ortho, para, and meta. Okay, when you are naming the compound. So with respect now here, so this is what, this is a phenol. Okay, with respect to OH, when you have the substituent, suppose the CH3 is here, so this is named as what? Orthocresol. Okay, or 2-methyl phenol. Suppose we have the compound like this, OH and the methyl position at third position. So it is 3-methyl phenol, or it is a metacresol. Okay, metacresol. Then if I have like this, OH and your CH3. So it is what? 1, 2, 3, 4-methyl phenol, or it is called as the paracresol. Okay, so based on the number of the where the substituent is given with respect to OH group as the first carbon, you have to give the numbering and give the name. Okay, yes. Let us see the functional group, structure of the functional group. So this is the functional group for alcohol. Okay, similarly, I write the functional group for your phenols. Okay, we will study both the functional group together. Okay, now here, so this is the functional group. Okay, so this is for phenol and that is for alcohol. So in alcohols, what you can see, the CO bond, okay, the CO bond, how it is formed? It is formed by the overlap of sp3 hybrid orbitals, okay, of the carbon and with the sp3 hybrid orbitals of the oxygen. Okay, then so this CO bond is formed by hybridization of sp3 hybridized orbitals of carbon with sp3 hybridized orbitals of the oxygen. Okay, then the COH bond, this your COH bond, okay, that is slightly less than the tetrahedral angle. So what is the tetrahedral angle? It is 109 degree 28 minutes. So the COH bond, it is slightly less than the tetrahedral angle. Why? What is the reason? Because of the repulsion between the unshared pair of electrons. Because there are two unshared pair of electrons, right, on the oxygen atom. So because of this unshared pair of electron, the bond angle is slightly less than that of the tetrahedral angle. Okay. Then when you see the phenols, now, when you see the phenols here, okay, the oxygen, that is the phenolic group, that is your OH group, it is directly attached to what? It is attached to the sp2 hybridized carbon. Where it is attached? It is attached to the sp2 hybridized carbon. sp2 means what? The carbon is next to a carbon, it is next to a carbon double bond. So we call that the OH group is attached to the carbon, sp2 hybridized carbon, okay, hybridized carbon atom of the aromatic ring. Now the CO bond, okay, this is the CO bond. This CO bond, the bond length is 136 picometer, okay, and this is slightly less than that of the methanol. In methanol, what was the bond length? It was 142. But when you see the bond length in phenol, it is slightly less. Okay, what is the reason? There are two reasons. First one, the sp3 hybridization of carbon. Okay, because of the sp2 hybridization of the carbon, what happens? It becomes more electronegative. Okay, and the second is that the CO bond has a partial double bond character. Okay, so due to which it comes with conjugation with the lone pair of electrons on the oxygen. Okay, with the benzene rings. These are the two reasons why the CO bond length is slightly less than that of the CO bond length in the methanol. Okay, so this is the structure of the functional group. So both the structures of the alcohol and the phenol is very important. Okay, so please go through this. Yes, so remember the things what have been told. Okay, so why the bond angle in alcohol is less? Why, if it is asked the question, why bond angle in alcohol is slightly less than the tetrahedral angle? Okay, because due to the repulsion between the unshared pair of electrons of the oxygen. Okay, that is the reason. Okay, yes, fine. Moving further. So let us see the methods of preparation of alcohol. So let us see the methods of preparation of alcohol. So first preparation, we are going to prepare the alcohols from alkenes. How we are going to prepare? We are preparing the alcohol. We are preparing the alcohols how? By preparing it from alkenes. So first is by acid catalyzed hydration. Okay, hydration means what? Adding of water. Okay, addition of water in the presence of acid. Okay, in the presence of acid. Acid catalyzed means we are adding water in the presence of acid. Okay, so let us take alkene. So let me take a alkene. So this is a alkene. We are going to add water in the presence of what? In the presence of the your acid. So acid, that is acid, what it releases? It releases protons. Okay, acid, it releases protons. So what will happen now? What will happen when you're adding water? So water is split into H plus plus OH minus. Okay, so across the double bond, Okay, so both the carbon atoms are symmetrical. Okay, both the carbon atoms. What do you mean by symmetrical? The number of atoms on either side of the double bond are same. So what will happen? So the carbon atom will get attached. So hydrogen will get attached one position and OH minus will attach at the other. So what I'm going to get? I'm going to get the alcohol. I'm going to get what? I'm going to get the alcohol. Is it clear? Okay. So this is the answer. So alcohols, how they are prepared? They are prepared by treating the alkenes. Okay, we have taken an alkene with water in the presence of acid as the catalyst. So we are making use of the acid as the catalyst. So this is the acid catalyzed reaction. Okay, is it clear? Is it clear? Okay. Let me give one more example. Okay. Let me give one more example. So CH3, CH, double bond, CH2 plus H2O. Okay, in the last, what we have seen, we have used uh, symmetrical alkene. Now here we have a unsymmetrical alkene. Here we have a unsymmetrical alkene. So whenever we have an unsymmetrical alkene, what we are going to do? We are going to follow the Markovnikov rule, right? We have used the Markovnikov rule, right? Yes, how the addition of the hydrogen halide takes place. Yes, how the addition of hydrogen halide takes place. It is going to take place according to Markovnikov rule. So what is Markovnikov rule? So now water is there, H plus and OH minus. It will split into H plus and OH minus. So what will be added? So this is a unsymmetrical alkene across the double bond. Okay, so across a double bond, the number of carbon atoms are not same. Then we say them as what? We say it as unsymmetrical alkene. So what will happen? The OH, the negative part will be added to the carbon with least number of hydrogens. Okay, so what I'm going to get? I'm going to get CH3, CHOH and CH3. So this is the addition product. What I've got? I've got propane to wall. Okay, propane to wall. So this is the answer. Okay, so how we are going to get? So first preparation is from acid catalyzation. Okay, we are going to get from acid catalyzed hydration. Okay, we are going to use acid catalyzed hydration. So alcohols, we are going to treat it with the alkenes, we are going to treat it with water in the presence of acid. Okay, and whenever you have symmetrical alkene across the double bond, at one carbon, hydrogen will be added. And in another carbon, what will be added? Another carbon, the OH will be added. Okay. But when you have an unsymmetrical alkene, we are going to use what? We are going to use the Markovnikov rule. Okay. We are going to use the Markovnikov rule. Fine. Let us go for the next one. So the very important preparation. Next, we are going to use the hydroboration oxidation. Okay, we are going to use the hydroboration oxidation. Okay, hydroboration oxidation, second method of preparation. So we are going to add across the alkene, we are going to add a diborane. Okay, we are going to add a diborane. What is diborane, student? B2H6. Okay, B2H6 is the diborane. So this is the structure of diborane. Okay, so this is the structure of diborane. So B2H6, 1, 2, 3, 4, 5, 6. Okay, and 2 boron. So what we are doing, we are treating the alkenes with diborane. And what will happen? At subsequent, you are going to do oxidation. Okay, and the hydrogens, okay, are going to be replaced with this borane. Okay, it is going to get oxidized. We are going to get the hydrogens will be replaced by the borane. And at last, we are going to, what we are going to do? We are going to use hydrogen peroxide in the presence of sodium hydroxide. We are going to get the alcohol. Okay. So now here let us do the reaction. So we are going to take propene. So let me take the reaction as CH3, CH double bond CH2. Okay, so I have taken a propene. I am going to add to that HBH2 twice. Okay, so this is the diborane. Okay, so diborane is what? B2H6. So that only I have written like this BH. Okay, 2 to the 4, and this is 5. Okay, so BH3, 3, 4, 5, 6. BH3 twice and H like this. Okay, so diborane. So what is going to happen? So what is going to happen across the double bond? Okay, your hydrogen will be added here, and so this will follow the whenever you are using hydrogen peroxide. So what will happen actually when we are doing whenever there is an unsymmetrical alkene and we are doing the addition reaction, it is going to follow the Markovnikov rule, right? But here, as we have already discussed, okay, in haloalkanes and haloarenes, then when we are using hydrogen peroxide, the reaction will go reverse, right? The reaction will go reverse. Why? Because it will follow the anti-Markovnikov rule. So here also the reaction will follow the reverse. So what will happen? The this what hydrogen will be added to the carbon with least number of hydrogens. Okay, to the carbon. So what I'm going to get? I'm going to get CH3, CH2, okay, and CH2 and BH2. So this is the answer. Now further again, what I'm going to do? So this with this, I'm going to react one more molecule of your alkene, that is CH3, CH double bond CH3. So what I'm going to get now? So what I'm going to get? Guess what I'm going to get here. So one of the again hydrogen. Okay, one of the hydrogen here will be replaced by your BH2 group. So what will happen? So I'm going to get CH3, CH2, CH2, okay, BH. Okay, BH. So one hydrogen is completely replaced by this. So one of the hydrogen is completely replaced by what? This group. Okay, further again, what I'm going to get? Again, I'm going to add one molecule of your propene. So what will happen? One more hydrogen is there. So I'm going to get CH3, CH2, CH2, and B. Okay. So I have got what? Trialkyl. So I've got the trialkyl. So here there are two. So this is 2, this is 3. So trialkyl. So I've got what? Trialkyl borane. Okay, I've got trialkyl borane. So at each step, each hydrogen is getting replaced. Okay, with the your alkene. So this is your what? Hydroboration oxidation. So by using hydroboration, we are going to get the alcohols. Okay, is it clear? Yes, I'll explain you once again properly. Here I'll write. So what we have done, we have taken a alkene. Okay, we are going to add BH3 twice. Okay, B2H6 is your diborane. So the reaction is occurring in the presence of hydrogen peroxide. So it will be reversed. Okay, the hydrogen will be added to the carbon with less number of hydrogens. So what I'm going to get? CH3, CH, CH2, okay, and BH2 and BH2. Okay. Now what I'm going to do? Again, I'm going to react it with one more molecule of your alkene. Okay. So what I'm going to get? One of the hydrogen will replace this all. So I'm going to get CH3, CH, CH2. Okay. Twice BH. Okay. Now further again I'm going to react it with CH3, CH double bond CH2. So again my hydrogen is there. So what I'm going to get? CH2 thrice B. So this is your trialkyl borane. Okay. So further, when I oxidize this, okay, in the presence of your NaOH, okay, when I do base hydrolysis, what I'm going to get? I am going to get the alcohol CH3, CH2, CH3, CH2, CH2, OH plus H3BO3. Okay, so the we are going to get the alcohol. So this is hydroboration reaction. Okay, so this is the fine. So let us go for the next one. So the addition of borane, okay, to the double bond takes place in such a way that the boron gets added to the sp2 carbon with more number of hydrogen atom. That is your anti-Markovnikov rule. Okay, it is your anti-Markovnikov rule. So already we have discussed the anti-Markovnikov rule, students. Okay. Next is the from carbonyl compounds. Next is from carbonyl compounds. So reduction of aldehydes and ketones. Okay, reduction of aldehydes and ketones. So aldehydes and ketones, they can be correspondingly reduced. Okay, by using it can be corresponding. So aldehydes and ketones, what they are done, we are doing, we are using aldehydes and ketones, and we are reducing it to corresponding alcohols by using some reducing agents. So which reducing agents we can use? Make a note. So we can use what we can use. Yes, we can use this. Okay, hydrogen in presence of nickel, platinum, and palladium catalyst. So this we can use. Then we can use sodium in presence of alcohol. Okay, sodium in presence of alcohol we can use. Then third one is lithium aluminum hydride and sodium borohydrate. Okay, lithium aluminum hydride and sodium borohydrate. So these are the reducing agents. So corresponding alcohols and ketones, aldehydes and ketones, they are converted into their reduced to their corresponding alcohol. So aldehydes and ketones, they are reduced by using this reducing agent to their corresponding alcohols. Okay. So let us see. Let us see. So if I give you the general this, okay, RCHO. Okay, RCHO is aldehyde. Okay, so aldehyde, when you react it with dihydrogen, okay, in the presence of nickel as a catalyst, what I am going to get? What I am going to get? What is reduction, students? Reduction means addition of hydrogen. So I am going to get CH2OH. So what we have done? We have added hydrogen. So where we have added? So these two hydrogens. So here one hydrogen, here one hydrogen. So I got CH2OH, right? CH2OH. So I got a primary alcohol. What I got? I got a primary alcohol. Similarly, if I give R as CH3CHO, what is that? Acetaldehyde. Okay, acetaldehyde. This acetaldehyde, when I react it with hydrogen in the presence of palladium, what will happen? CH3, here one hydrogen, here one hydrogen. So I get CH3, CH2OH. Yes, students, is it clear? What I have got? CH3, CH2OH. So primary alcohol is formed. Okay, now we will see reduction with your ketone. Okay, let me take a ketone. So any of this reducing agent you can use. So ketone is represented as what? RCO R dash. Okay, when you react it with hydrogen, okay, we are going to do reducing agent using a lithium aluminum hydride. Okay, as a reducing agent, what I'm going to get? What I'm going to get? So R CH OH R dash. Okay, so across the double bond, I'm going to get add the hydrogen. So here one hydrogen, here one hydrogen. So I got RCH R dash OH. Okay, so I got a secondary alcohol. So primary alcohol are sorry, your aldehydes are when they are reduced. Okay, they are going to reduce to primary aldehydes are reduced to primary alcohols, and ketones are reduced to corresponding secondary alcohols by using this agents. Okay, reducing agent. So let me take an example for your ketone. So this is acetone. Okay, I'm going to use sodium borohydrate. Okay, what will happen? Same. I'm going to add the hydrogen. So one hydrogen is added here. One hydrogen is added here. So it will be CH3, CHOH, and CH3. Okay, so this is the answer. Is it clear, students? So reduction of aldehydes and ketones. Yes? Okay. Next is reduction of carboxylic acid and ester. Okay, reduction of carboxylic acid and ester. So lithium aluminum hydride. So it is a good reducing agent and reduces the carboxylic acid to primary alcohol. Okay. So when we are using esters, when we are reducing the carboxylic acid and esters, they are correspondingly reduced to primary alcohol. So now what we have taken, so let me take the general. So generally, so R C double bond O OH. So this is the carboxylic acid. So I am going to use lithium aluminum hydride. Okay, followed by hydrolysis. So what I'm going to get? I'm going to get a alcohol. I'm going to get a alcohol. So what is added? Hydrogens are added. So reducing. So what is added? So hydrogen. Here one hydrogen. Okay. So I'm going to get what? RCH2OH. Okay. RCH2OH. So it is. So your oxygen is removed and hydrogen is added. Okay. Oxygen is removed and hydrogen is added. So what do you mean by reducing agent? Reducing agent, they are used to adding the oxygen, removing the oxygen and adding the hydrogen. Okay. Yes. So both the oxygens are replaced by the hydrogens. And we are going to get the corresponding alcohol. Yes. Alcohols are prepared on commercial scale by converting the acids to esters followed by the reduction with hydrogen in the presence of catalyst. So when I want to prepare the alcohol at the commercial scale means what? When I want to prepare in large quantity. So I cannot prepare directly from alcohol. So what the steps are? The alcohol carboxylic acid, when they are reacted with the alcohol, you get ester. Okay, they are converted into, the acids are converted into esters. Okay, and then you are going to do the reduction with hydrogen in the presence of catalyst to alcohols. Okay, so I have got a mixture of alcohol. So this is the ethanol, another is the methanol. So I got what? Mixture of alcohols. Is it clear? Yes. Okay. So these are the preparation of aldehydes. Next is by reduction of carboxylic acid. Okay. So that we have done. Next we are going to see is the Grignard reagent. Okay. Grignard reagent. So Grignard reagent, when they react, okay, with aldehyde and ketones, they form alcohols. They form what? Alcohols. Okay. So here you can see. So when I have okay, plus RMGX. So what will happen? Here, the alkyl group will attack the carbonyl carbon, and that as a result, there will be generation of this. So this is partial negative, this is partial positive. Okay, so what it will do? So our alkyl group will attack the carbon, it will polarize the carbonyl carbon group. And what I'm going to get? I'm going to get CR. So R will go and attach. So this will be O minus Mg plus and X. Okay. So what will happen now? Further, we are going to add water. Okay. Further, we are going to add water. So when we are adding water, so what will happen here? So hydrogen will be added here and the OH will be added at the other side. So further, when we do acid hydrolysis, what we are going to get? RCOH plus Mg, X and OH. So these are the products. So Grignard reagent, when you react it with aldehydes and ketones, you will obtain the alcohol. So this is the respective alcohols. Okay. So let us take the examples. Let us take the example, students. Yes, take the example. Yes, so here, so what we have done, so this is the Grignard reagent, RMGX, okay. So this is partial positive, this is partial negative. So it will tend, so this will contact, this will polarize. So what I'm going to get? So I'm going to get C, okay, R O minus mgx plus and x. So what will happen here? Addition of water takes place. So here H will be added, here OH will be added. So what I'm going to get? In the presence of water and acid, I'm going to get COH R plus mgx and OH. Okay, so this is the reaction. Now let us follow this and do the reactions with different aldehydes and ketones. So let me take both this as hydrogen. Okay, so when these are both hydrogen, we call it as formaldehyde. What we call? We call it as formaldehyde. So this formaldehyde, okay, when it reacts with RMgX, when it reacts with RMgX, so again, this will be again, okay, so what I am going to get? I am going to get, so HCO minus, okay, R, then R, here. So here will be H, here will be one more H, here will be R, here will be O minus Mg plus and X. Okay, now again addition of water takes place. So here H plus, here OH minus. So what I'm going to get? I'm going to get RCH ROH plus Mg X and OH. Okay, so in the presence of acid hydrolysis. So what I got? I got a primary alcohol. So with formaldehyde, I'm going to get a primary alcohol. Next, what I'll do? I'll take a aldehyde. So one aldehyde, okay. So one will be R, another will be H. So this is your form. In formaldehyde, both will be hydrogens. Okay. Now here what we have done? So here we have taken one as alkyl group. So react it with RMgX students. So again, this will react. Okay, this will polarize. What I am going to get? R, C, H, R, O minus, Mg plus X minus. Okay, so again, addition of H plus here and OH minus here in the presence of water, that is acid hydrolysis. What I'm going to get? R, C, H, R, OH plus Mg, OH and X. So again, two R groups. So this is a secondary alcohol. Okay. Now let me take a ketone. So let us react the aldehyde with the ketone now. Okay. Let us react. So let us R, C. Ketone means what? Both will be the alkyl group. Okay. So let us take R, Mg, X. Okay. So what I'm going to get? So this will polarize this here. So what I'm going to get? So R, C, R dash, and this is R double dash, O minus Mg plus and X. Okay. So here across this, I'm going to add H. Here I'm going to add OH. That is in the presence of acid hydrolysis. What I'm going to get, students? I'm going to get a, what is that? I'm going to get a tertiary alcohol. Yes, is it so? So you can get a tertiary alcohol. So what you can say that when I'm using a formaldehyde with Grignard reagent, I'm going to get a primary alcohol. When I'm using a aldehyde, okay, aldehyde, except your formaldehyde, okay, one alkyl group should be present, then it will give you a secondary alcohol. When you are using a ketone, okay, when you are using a ketone, you are going to get what? Tertiary alcohol. Okay, you're going to get a tertiary alcohol. Is it clear? Yes, is it clear, students? Yes, is it clear? So these are the methods of preparation of your alcohols. Yes. Okay. So Grignard reagent reactions are very important. Okay, Grignard reagent reactions are very, very important. So they have asked. So based on this, okay, so if they ask you to form the secondary alcohol, so what you are going to use with Grignard reagent? You are going to take a aldehyde. Okay, and this aldehyde, except the formaldehyde, any aldehyde you can take. Okay, any aldehyde you can take. Yes. Okay, fine. So Grignard reagents, we get the alcohol. Yes. So preparations of phenols. Okay, we'll see these two phenols and then we'll stop. So the preparation next is the methods of preparations of phenols. So how we can prepare the this what phenols now. We have completed the methods of preparations of alcohol. So next is the methods of preparation of phenols. Okay. So you have to take a uh, using the haloarenes. Okay. Now we know what are the haloarenes. So by using haloarenes, we can prepare the alcohol phenols. Okay. So chlorobenzene is taken. We are going to fuse it with NaOH at 623 Kelvin and 300 atmosphere pressure. What I'm going to use? I'm going to get a sodium phenate. I'm going to get a sodium phenate, or you call sodium phenoxide. So what is happening? The Cl is replaced by O minus Na plus. So I get a sodium phenoxide. Okay. So chlorobenzene, we are going to fuse it with NaOH at 623 Kelvin and 320 atmospheric pressure. I am going to get sodium phenoxide. This sodium phenoxide, I am going to do further acidification. So for doing acidification, what we require any acid. So I am taking HCl. So what it will generate? It will generate protons. So what will happen? Your Na plus ions will be replaced by H plus ions. So I am going to get a phenol. Okay, your Na plus ions will be replaced by H plus ions. I am going to get a phenol. So this is the first methods of preparation from haloarenes. Okay, very important. So very important preparation where we can prepare the phenol by using haloarenes. Okay. Then the next is from benzene sulfonic acid. Okay, very, very important. Mark this as important. So both these are very important. So mark this important. So from benzene sulfonic acid. So benzene first we are sulfonating it. Okay, we are going to sulfonating by using oleum. What is oleum? They'll ask you the formula of oleum. It is H2S2O7. Okay, it is H2S2O7. So first we are going to sulfonate the benzene with oleum to form benzene sulfonic acid. So this is our benzene sulfonic acid. So by using the sulfonic acid, by using oleum, we are going to sulfonate it first. Then I'm going to do what? Further, I am going to convert this benzene sulfonic acid. Okay. I'm going to do base hydrolysis. Okay. That is, I'm going to convert it to sodium phenoxide. I'm going to convert it to sodium phenoxide. Okay. Further acidification will give you a phenol. Okay. Further acidification will give you a phenol. So this is the reaction that is from benzene diazonium, benzene sulfonic acid. So what we have done? So we have taken the benzene, we are reacted with oleum. So oleum, what I'm going to get? I'm going to get the sulfonic acid, that is SO3H. This sulfonic acid, further I'm going to react it with, what is that? Your NaOH. What I'm going to get? I'm going to get the O minus Na plus. Okay. I'm going to get your sodium phenoxide minus Na2SO3. Okay. This will be given out. Further, I'm going to do again acidification. Your Na plus ions will be replaced by H plus. So this is the preparation of phenol. Is it clear? Yes, students, is it clear? Yes. Okay. Further, next is from cumene. Next is from cumene. So another important question. So all these name reactions are your, this is important. So mark this also important for 2 to 3 marks. Okay, very important question. That is from cumene. So, very important question. So, phenol. Okay. So, how we are going to prepare this cumene, that is your isopropyl. So, I'm going to take a benzene. I'm going to react it with propene. CH3, CH double bond, CH2. In the presence of your phosphoric acid, okay, at 523 Kelvin, I am going to get your cumene. Okay, I'm going to get you the cumene, that is CH, CH3, CH3. Okay, so how to get this? The step is this. So I'm going to take benzene. I'm going to react it with propene. Okay, at with the presence of what? In the presence of H3PO4 at 523 Kelvin, I am going to get a what? Isopropyl alcohol benzene. Okay, I'm going to get a isopropyl benzene. Now this isopropyl benzene, which is called as the cumene, further what we are going to do? We are going to do oxidation. Okay, oxidation in the presence of air. So what will be added? So across this H, okay, across this H, what is added? Oxygens are added, a double bonded that is added. So COOH, CH3 and CH3. Now further, I am going to do what? Acidification. Okay, cumene. So this is your cumene hydroperoxide. Hydroperoxide, why? When you have a double OO linkage. Okay, when you have a OO linkage, it is called as what? It is called as the hydroperoxide. Okay, linkage is called as hydroperoxide linkage. So cumene hydroperoxide. Further, I am going to treat it with HCl. Okay, I am further going to treat it with HCl. Okay, in the presence of water, I am going to get what? I am going to get a phenol and plus the major product, that is the acetone. Very, very important. So both these products has to be written. Okay, I'm going to get phenol and acetone. Is it clear? Is it clear, students? Yes. Okay. So from cumene, very, very important. So how to prepare cumene? Benzene, you're going to react it with propene in the presence of H3PO4. Okay. At 523 Kelvin, I'm going to get isopropyl benzene. This isopropyl benzene, I'm going to do oxidation in the presence of air. I'm going to get cumene hydroperoxide. This cumene hydroperoxide, further, I'm going to treat it. I'm going to do acid hydrolysis to give you phenol and acetone. Okay. Yes. So this is the preparation. Okay, this is the preparation of phenol. Okay. So byproduct is very important. Okay, phenol and acetone, you have to write it as a byproduct. Okay. Then next is from disonium salt. Next is from disonium salt. So how we can prepare the phenols? So I'm going to take aniline. So this is aniline or benzonamine. Okay, I'm going to react it with nitrous acid. So how to get this nitrous acid? NaNO2 plus HCl. Okay, when you react NaNO2 with HCl, I am going to get nitrous acid. Okay, I'm going to get this nitrous acid. So this nitrous acid will react with this aniline at 273 to 78 Kelvin. Okay, that is 0 degree to 5 degrees Celsius. I am going to get a benzene disonium chloride. Okay, the temperature is very lower. Okay, you have to maintain this temperature. If you don't maintain this temperature, you're not going to get this benzene disonium chloride. So benzene disonium chloride, what if I am going to do further? I'm going to heat it, okay, with water and I'm going to get a phenol. Okay, I'm going to get a phenol. So very, very important. Okay, mark this also important. That is the preparation of phenol from disonium salt. Okay, preparation of phenol from disonium salt. Okay, so these are the four important preparations of phenols. Okay, so which all preparation we have seen? From haloarenes, okay, then from benzene sulfonic acid, from cumene and from disonium salt. Okay. So in today's class, we have seen the definitions, okay, the general formulas, how to write for alcohols and phenols, ethers. Then we have seen the classification of alcohols and phenols. Then we have seen the structural, that is the structure of the functional groups, okay, of alcohols and phenols. Then we have seen the IUPAC nomenclature of alcohols and phenols. Then we have started with the methods of preparations of alcohols, as well as we have completed the methods of preparation of phenols. Okay. So in the next class, we are going to see the physical properties of alcohols and phenols. I hope you have understood the things which have been told in today's session. So tomorrow also, we are going to continue with the same topic, that is alcohol, phenols and ethers. Yes. Okay, so I shall stop the class today. We'll continue in the next class. Thank you.